In the summer of 2015, a number of scientists from NOAA published a paper in the journal Science. This is probably one of the world's most prestigious scientific journals, led by Tom Carl. So it was the Carl et al. Paper. And in this paper, they updated NOAA's global temperature record. In particular, they updated NOAA's sea surface temperature record to a new version, version 4 from version 3. And in the process, they increased the amount of warming that we've experienced pretty significantly. They roughly doubled the temperature trend since 1998 compared to the old version of the data set. This proved fairly controversial. Congress ended up investigating NOAA. A number of senators and representatives accused them of cooking the proverbial books. The House Science and Technology Committee even subpoenaed NOAA to get all their scientists' emails of scientists who were involved in the study. So it became quite a political hot potato. It also led to some interesting scientific questions because the new NOAA record is both warmer than their old record, but also a bit warmer than the Hadley Center's record in the UK, which is probably the most commonly used global temperature record. Now, where these changes really came down to is how they dealt with the oceans. The land temperature in the new version, the old version, is pretty much the same. And the big change in the oceans is how they deal with changing measurements in the oceans. Until the early 1990s, ocean measurements were primarily taken by ships, and in recent years, primarily by engine intake valves on ships. So you're pulling water from the ocean through the hull into the engine room, you're taking the temperature. Unsurprisingly, it turns out that engine rooms in ships are a bit warmer than the ocean outside of ships. Starting in the mid-1990s, however, they switched over to taking most measurements from buoys because the buoys started being deployed. These buoys, they're pretty awesome little things. They drift around, they send their data up to satellites automatically, you don't need people involved, and there's thousands upon thousands of them now taking measurements in real time all throughout the oceans. And so now the vast majority of our measurements come from these buoys. The buoys sit directly in the water, and therefore they take temperature of the water directly, and it turns out that the temperatures the buoys are taking is a bit colder than the temperatures that you're getting in ship engine rooms. And so the switch from ships to buoys introduced a cold bias. NOAA wasn't previously accounting for it. In their new record, they do account for it. What they also do, however, is they give buoys a lot more weight than the ship data, because they assume that buoys, all the buoys are the same, they all are directly in the water, whereas ships, they differ in size and speed and how deep the hull is, a bunch of factors that can influence temperatures. And NOAA thinks the buoys are better, so they put more weight on them. And Hadley also corrects for the difference between ship engine rooms and buoys, but they don't necessarily weight the ships or the buoys any differently. And so we wanted to figure out what was driving this difference between the old NOAA record, the new NOAA record, and the Hadley record, and which of them was the most accurate. And it turns out in the last 15 years where this divergence has really occurred, there is a wealth of new data measuring the Earth's oceans that we can use to solve this problem, to figure out which record is actually the most accurate. And to do it, we constructed what we call instrumentally homogeneous sea surface temperature records. So instead of trying to splice together ships and buoys and all these different measurements and having to figure out offsets and adjustments between them, let's just look at sea surface temperature records created by one instrument. Let's only look at buoys. Let's only look at data from satellite radiometers, which are completely independent. None of the groups are using them right now in their sea surface temperature estimates. Let's take a look at sea surface temperature records just from Argo floats, which are these awesome little robots that dive deep down in the ocean, come back up, and take the temperature as they go. No one uses them right now, so they're completely independent. And so we created 3 separate independent sea surface temperature records, and we compared those to the old NOAA record, the new NOAA record, and the Hadley record. And what we found is all 3 of them agreed almost perfectly with the new NOAA record, at least on a global scale, and showed a strong cooling bias in the old NOAA record. They also showed a significant cooling bias in the Hadley record, which was something of a surprise to us. And what appears to be happening is that as we've switched to taking most of our measurements from buoys, we're also taking less measurements from ships. And the nature of ships has changed in the last 15 years. You have bigger ships, they have deeper hulls, you have all these big cargo ships now that you didn't necessarily have as many of 15 years ago. And so that's changed the measurements from ships in ways that has introduced a bit of a cold bias in the ship data. NOAA gets around this by just weighting the ship data less because they think the buoys are more reliable, so they end up with a record more similar to the buoys. Hadley seems to fall afoul of this ship-related cold bias because they don't assign any more weights to the buoys than the ships. And so these results serve as a robust, independent validation of the NOAA temperature record and show us that the new NOAA temperature record is probably the best estimate of global ocean temperatures over the last 15 years. They show that NOAA scientists weren't cooking the books, and that there is a cool bias in the Hadley data and the Japanese Kobe data, another data set we looked at, that need to be addressed going forward.